students, welcome again to another lesson for maths. Now last time we looked at solving simultaneous equations using substitution method. We will continue today, but this time we'll be looking at the other method, the other algebraic method for solving simultaneous equations. This time the elimination method. So if you're ready, let's begin. Now, of course, we'll be looking at a couple of examples, just like we did the last time. So I will start an example and use the example to explain the steps we follow when we're solving any given pair of simultaneous equations using elimination method. So I will start today with an example as usual. So here's an example. Given that 3x plus 7y is equal to 1 and x minus 7y is equal to 19, then x plus y is equal to what? Right, now you have to be careful here. Careful because once you've gotten the values of x and y, you do not stop there. That is not your final answer. You still have to go a step further because the question says x plus y is equal to what? So when you get the values of x and y, you now need to go a step further by adding the values of x and y to get your final answer. Okay, so always take note of that and read your questions very carefully. Alright, so let's start. Well, first thing first, we have to write down the given equations like I could normally would, which are equation 1 and equation 2. So I have my equations 1 and 2 as follows. The given equation, that's 3x plus 7y is equal to 1. We're making that our equation 1, and x minus 7y is equal to 19. We're making that our equation 2. Alright, so like I said, the two algebraic methods we'll be considering substitution method and elimination method. But in the last lesson, we saw how we could use substitution method. And like I said, for today, we'll be looking at how we use the elimination method. Now, of course, you might want to argue that given this pair of simultaneous equations, we can use substitution method. Yes, because you can still recollect from the last class, I did mention that where the coefficient is 1, then you can use substitution method by making that variable with a coefficient of 1 the subject. But we did that last week, okay? We don't want to go over using substitution method again this week, but rather we'll see how we use elimination method, okay? So we'll skip substitution method for today's lesson and rather concentrate on using elimination method, okay? So let's see the steps involved in using elimination method to solve the given pair of simultaneous equations. Step 1, you look at the coefficients that is the same, okay? In equation 1, the coefficient of y is 7, or if you like plus 7 if you take the sign into consideration. But for now, let's ignore the sign. Let's just concentrate on the coefficient, which is the number before the letter. So the coefficient of y here is 7. The coefficient of x there is 3. The coefficient of x in equation 2 is 1. You know, but we don't normally put the 1 there, but it's actually there. So the coefficients of x in both equations are not the same. So we ignore that for now. But look at the coefficient of y in equation 1, which is 7. The coefficient of y in equation 2 is also 7. Aha! So the coefficients are the same. So this is how you start to use the elimination method. You look for the variable with the same coefficient. Are different. Aha! We have a code here. When the signs are different, and when the signs are the same. But obviously here, the signs are different. So when the signs are different, what do you do next? So I have some short codes here that can help you remember. You have SSS and DSA. SSS and DSA. SSS, which is short for same sign, you subtract. DSA, which is short for different signs, you add. So once the coefficients are the same, you look at the signs, and obviously here the signs are different. Because the signs are different signs, we will add the two equations. So take note. So where the signs are the same, for example, if you've got plus and plus, which is the same, or minus and minus, which is the same, where the signs are different, sorry, where the signs are the same, I should say, you have plus plus or minus minus. Same sign, we will subtract. But obviously here where the signs are different signs we will add. So take note of that. But not to worry, we'll look at some more examples to explain even better and help your understanding. So obviously here, the signs are different. Because the signs are different signs, we will add to equations. So let's see how we add. So you put your line below and then the plus sign to add. Now when you add, the 3x from equation 1 plus the x from equation 2 gives you 4x when you add the two together. But then what happens to the y? Now of course take note, plus times this minus gives you minus. So you have 7y minus 7y. 7y minus 7y gives you 0. So we eliminate y. Y is eliminated. That's how the idea of elimination comes in. We've eliminated the variable y. And then moving on, 1 plus 19 gives you 20. Aha. So now we have just one unknown, x. And from here, it's easy to find the value of x. To get x, you simply divide both sides by 4. And so x will be 20 divided by 4. When you divide 20 by 4, you get as the value of x to be 5. So there we go, we have the value of x. So given this value of x, we now go a step further by putting this value of x in equation 2, as it is in this case, to find the corresponding value of y. Now the choice is yours. You can decide to put this value of x in equation 1. But you see, I always go for the more convenient option, the easier option. Easier because x here has got a coefficient of 1, or where the x has got a smaller coefficient. X has got a bigger coefficient there, so when you multiply, you tend to get a bigger value. So that's why it's easier, it's more convenient to go for a smaller value rather than a bigger value. So with x being equal to 5, we put this value of x in equation 2. So anywhere you see x, it will be replaced with its value, which is 5. And from there, we should be able to find the corresponding value of y. So in equation 2, which is originally x minus 7y is equal to 19, we now replace the value of x, which is 5, in that equation. So you have 5 minus 7y is equal to 19. And from there, we can then solve for the value of y. How do we do that? We keep this, we make this a subject, and then move the 5 to the right-hand side. Okay? So you move the 5 to the right-hand side, and when you do that, the sign changes. The sign there is positive, but then when you move it to the right-hand side, it becomes negative. So you have minus 7y is equal to 19 minus 5. And 19 minus 5 obviously gives you 14. So you have minus 7y is equal to 14. And if minus 7y is equal to 14, to get y, you divide both sides by minus 7. So you have y is equal to minus 14 over 7. And we divide 14 by minus 7, get as the value of y to be negative 2. So there you go, we have the value of x, which is 5, and then the value of y, which is minus 2. But like I said, do not stop there. You do not stop there, because the question says, then x plus y is what? So we still need to go one step further. Having found the value of x and the corresponding value of y, we don't stop there, because the question says we need to find the addition of x and y. So we go one step further. If you stop there, you, I'm afraid, will not get full marks. So you've got to be careful. We need to go one step further, following from the question. Okay? So what do we do next? Given the values of x and y, therefore, x plus y, which is what the question asks us to find, x plus y will not be equal to the value of x, which is 5, plus the value of y. Y is minus 2. So you have 5 plus and minus, minus 2. Now remember from your golden rules, plus times minus, when you open the brackets, gives you minus. So you have x plus y to be equal to 5 minus 2. And 5 minus 2 gives you 3 as the value of x plus y. And so that is your final answer. So there you go, that is your final answer. And you are done. So this is how we go about solving any given pair of simultaneous equations using the elimination method. Now, like I said, if you don't quite follow all the steps, we'll look at another example with the same set of steps, but seeing or using a different set of equations. Again, I'll show you how we can apply the elimination method following the same steps to solve the given simultaneous equations. So, having said that, let's move on to the next example. So here's the next example. You've asked to solve the following pair of simultaneous equations. 2x plus 5y is equal to 6.5. That's equation 1. And then 5x minus 2y is equal to 9. Now, wherever you have a mixed number, okay, I try as much as possible to write that as an improper fraction. So the 6.5, I would prefer to put there in its place 13 over 2, because that's what you have when you convert the mixed number. Now, like I said, you have 6.5, which is a mixed number. I am more comfortable with having an improper fraction in place of the mixed number. And so when you convert a mixed number to an improper fraction, you get 13 over 2. And how do you get that? You simply multiply the 2, which is the denominator, by that number to your left. 2 times 6 gives you 12, and then you add the numerator. 12 plus 1 gives you 13. So 6.5 converted to an improper fraction gives you 13 over 2. So for now, let's just ignore that. Ignore the mixed number, and in its place, let's put 13 over 2. Okay, so your equation 1 now is 2x plus 5y is equal to 13 over 2. Okay, that's much better. That's a lot better than having the mixed number there. And then, of course, for equation 2, 5x minus 2y is equal to 9. And so, like I said, again, want to see how we use the elimination method. Now, obviously, here we cannot use a substitution method. You know why? I said the necessary condition, the condition that is required and necessary for you to decide using substitution method is for you to have any of the variables with a coefficient of 1. And obviously here, none of the variables has got a coefficient of 1. I mean, look at x from equation 1. The coefficient is 2. The coefficient of y is 5. The coefficient of y in equation 2 is 2, or like minus 2 if you take the sign into consideration. And then the coefficient of x is 5. So none of these has got a coefficient of 1. So you cannot use substitution method. Forget it. You can't use substitution method in this case. So undoubtedly, you're left with the other option, which is using the elimination method. So there we go. Let's follow the steps again and see how we will solve this given pair of simultaneous equations using the elimination method. First thing first. Well, obviously in this case, the coefficients are not the same for the two equations. If you look at the coefficient of x from equation 1, 2, the coefficient of x from equation 2 is 5. They're not the same. The coefficient of y from equation 1 is 5. The coefficient of y from equation 2 is 2. Again, they're not the same. So you have to, first of all, make the coefficients the same for both equations. Now the choice is yours. You can either go for x and make the coefficients the same, or you go for y and make the coefficients the same. Okay? So You choose one, like I said, either x or y, and then make the coefficients the same. And how do you do that? Using the LCM, which is short, of course, for the least common multiple. So, let's see, I think I chose y. So, I decided to take y. So let's go to the coefficient. The coefficient of y here is 5 from equation 1, and the coefficient of y from equation 2 is 2. So we find the LCM of 2 and 5. The LCM of 2 and 5 is 10. LCM of 2 and 5. 2 and 5 is 10. And so what it means is we are going to multiply the whole of equation 1 by, because we already have 5 there. Now, right, so we already have 5 there. So to get 10, which is LCM, we'll multiply the whole of that by 2. And then you've got a 2 here. To get LCM of 10, we'll multiply the whole of that by 5. Okay, and that's where the idea of 2 times the whole of equation 1 comes in right there, and then 5 times the whole of equation 2 right there. Okay, so now of course to make things less confusing, I'm going to have to erase some parts here. Okay, so we've changed, okay, we'll just leave that. Okay, right, so let's continue. Right, so we multiply the whole of equation 1 by 2, and then we multiply the whole of equation 2 by 5. So 2 times 2x gives you 4x. Well, this is what we have. 2, so you multiply the whole of that by 2. 2 times 2x gives you 4x. 2 times 5y gives you 10y. And then 2 times 13 over 2. Now remember, the 6.5 has been converted to 13 over 2. When you multiply that by 2, that 2 will simply cancel the denominator, and you're left with just 13. And that's the 13 over there. Alright, so we'll call that equation 3. Okay? Just for confusion, to avoid any confusion. Next up, we multiply the whole of equation 2 by 5. So 5 times 5x gives you 25x. Minus 5 times 2y gives you 10y, and that's equal to 5 times 9. That gives you 45. So we have another equation, and we would like to call that equation number 4. So at this point, we will concentrate on these two equations, equations 3 and 4. And as you can see clearly, now the coefficient of y is the same in equation 3 and equation 4. Now the coefficient of x is not the same. X is having a coefficient of 4 in equation 3 and a coefficient of 25 in equation 4. It's not the same, so we're not going to concentrate on that. Rather, we'll concentrate on y with the same coefficient. Alright, so where the coefficients are the same, which is y here. So for those of you who cannot see, I've actually highlighted that. So clearly you can see the coefficients are the same. Now look at the signs. Look at the signs. Just before the coefficient, the signs are obviously different. You've got a plus and a minus. Now remember the DSA and the SSS. DSA and SSS. SSS, which is short for same sign subtract. And then DSA, which is short for different signs you add. Well, obviously, the signs are different, plus and minus. Different signs, add. So in this case, we are going to add the two equations, 3 and 4. So let's see how we add them. So when you add the two together, just like we did in the last example, 4x plus 25x, that gives 29x. And then when you look closely again, this plus times minus gives you minus. So you have 10y minus 10y. The y is eliminated. So we've gotten rid of y. Y goes. And then you have equal to 13 plus 45. 13 plus 45 gives you 58. So there you go. We have just x now, and it's so easy to find the value of x. If 29x is equal to 58, sorry, therefore x will be 58 divided by 29. And of course, when you divide 58 by 29, what do you get? You simply get 2. So there you go. We have the value of x. X is 2. So now, with this value of x, we put it in equation 2 to get the corresponding value of y. Now, like I said, the choice is yours. You can either go for equation 1 or equation 2. But like I said, I would prefer to go for the easier option. And the easier option is the one with a smaller coefficient. So, if you look at x, or we already have the value of x, so we don't worry too much about x. But y now, the question of y there's 5, the question of y there's 2. It's bigger there, so ignore that, because when you multiply by a bigger number, your value tends to be bigger. Okay, when you multiply by a small number, the value tends to be smaller. So that's why I decided to go for equation number 2. So you put this value of x in equation 2. And when you do that, what it simply means is, anywhere you see x, you replace with its value in equation 2. Alright? And so we have 5 times x. So the x will now be replaced with 2 in equation 2. Minus 2y is equal to 19. And of course, when you open the bracket, you have 10 minus 2y is equal to 9. Now we're trying to find y. So you keep this, but then you move the 10 from the left hand side to the right hand side. Okay? And when you do that, the sign changes. And so you have minus 2y is equal to 9 minus 10. And 9 minus 10 is minus 1. So you have minus 2y is equal to minus 1. And then to get y, you simply divide both sides by minus 1. And when you divide both sides by minus 1, what do you get? The minus will cancel. And you will have as your final answer, y is equal to half. Okay? So, there's the value of x, there's the value of y. But then, because you're not asked anything else, you're just asked to solve the simultaneous equation. And when you solve the simultaneous equation, your solution will be the value of x and the corresponding value of y. But you see, it's important to always check to be sure that yes, indeed, these are the correct values. And how do we check? We simply put these values, the value of x and the corresponding value of y, into the original equations, just to be absolutely sure that what you have on the right hand side are indeed what you will end up getting. So let's just have that quick check. So when x is 2, 2 times 2 gives you 4. Plus y is half. Now you have 5 over 2. Now remember, 5 over 2 is the same as, now this is of course an improper fraction. To change an improper fraction to a mixed number, that's 2.5. Because 2 goes in 5 just twice, remaining 1. So 4 plus 2.5. 4 plus 2.5 gives you 6.5, which is correct for the first term equation. Now let's just try if it will be correct for the second equation. If it is, then undoubtedly this will be the values. Right, now like I said, now that we have these two values of x and y, it's important for you to be able to check that these are indeed the solution to the given pair of simultaneous equations. And how do we check? You substitute, or you put these values of x and y in the original given pair of simultaneous equations, and if what you get corresponds to what you've got on the right hand side, then yes indeed, these are the solutions to the given pair of simultaneous equations. So let's just go ahead and carry out the check. Now, with x being 2 and y equal to half, so anywhere you see x, correct. Replace with 2. So you have equation 1, 2x, that's 2 times 2, that gives you 4. And then plus y. Y is half. 5 over 2. Now 5 over 2 is an improper fraction. Improper fraction converted to a mixed number gives you 2.5. So 4 plus 2.5, that is 6.5. So it's correct for equation 1. Now let's just check if it's correct as well for equation 2. Again, x is 2. 5 times 2 gives you 10 minus y is half. Y is half, so 2y will be 2 over 2. And 2 over 2 clearly gives you 1. And so you have 10 minus 1. And that gives you 9. So it's also correct for equation 2. So now, without any doubt in our mind, these are the solutions to this given pair of simultaneous equations. Alright? So these clearly are the steps we follow when we're solving any given pair of simultaneous equations using elimination method. Now, I have another example which I'd like us to go over together as well. Okay? So, example 3 now, and this is looking a bit funny. Alright? But do not fret. Do not get nervous, or do not get that question, or don't let that question put you off. When you're given a question like that, just take your time and have a closer look at the question, and then start thinking of ways you can solve it. Okay? Do not be a lazy student such that when you're given a question, you see it looking so complicated, you simply give up by saying, I don't understand. No. Give yourself that little push. Give yourself that little challenge, and give it a go. Now the question reads, using the expression P is equal to 1 over x and Q is equal to 1 over y. Solve the simultaneous equations. 1 over x minus 5 over y is equal to 7, that's equation 1. And then 2 over x plus 1 over y is equal to 3, that's equation 2. Okay? So, but bear in mind, you've been given this, and the reason why you've been given these expressions is to make the steps a lot easier for you to solve. So, P is equal to 1 over x. So, anywhere you see 1 over x, you replace with the letter P. And anywhere you see 1 over y, you replace with the letter Q. So when you do that, in the two equations, we will now have this. Okay? For those of you who can't see that immediately, I'll go over with you together. Look at 1 over x. That's a P. So this is replaced with P. 1 over y. That's a Q. So imagine you have a 1 over there. 1 over y. That's your P, that's your Q rather. So you have minus 5Q is equal to 7. So because we've slightly changed equation 1, let's call that equation 3. And then again, 2 over x. Now remember, 1 over x is a P. So 1 over x. So you have 2P and then plus y. Aha, your y is your Q is 1 over y. So you replace the 1 over y with Q. And that is equal to 3. So again, because we've changed equation 2, we'll call that equation 4. So now you can see that although we started off with something that's looking a bit confusing, a bit so off-putting, we've now changed it, we've now transformed it, giving these expressions for P and Q into something that looks a bit more familiar, which we should be able to solve. Although now we've changed the variables from x and y to P and Q. It doesn't matter. It doesn't really matter. Alright? So all we need to do now is to solve this derived simultaneous equations to get the values of P and Q. And once we've done that, we can then put the values of P and Q there to get the corresponding values of x and y. Alright? So now let's proceed. So again, are we going to use substitution method or elimination method? Now, like I said, for you to use substitution method, you need to look for the variable with a coefficient of 1. Now, P has got a coefficient of 1 there, which means yes, indeed, you can use substitution method. And then when you look at equation 4, the Q there has also got a coefficient of 1, which means you can also use substitution method. But like I said, in the last class, we saw how to use substitution method, alright? So, but this time around, I want to concentrate on using elimination method, because sometimes a question might insist on you using a particular method, and that's why it's important for you to know how to use the two methods, alright? So for today, we'll concentrate on using the elimination method. And I'm going to show you the steps we'll follow, just like we followed before now in the previous examples. Again, we check to be sure that the coefficients are the same. Well, obviously the coefficients are not. The coefficient of P there is 1, the coefficient of P there is 2, not the same. The coefficient of Q there is 5, well if you take the sign, minus 5, and the coefficient of Q there is plus 1, again not the same. So the idea is for you to always make the coefficient the same in the two equations. So again, you choose one, the choice is yours. You either go for P or Q and make the coefficient the same by using the LCM. Now I've decided to go for P. And like I always say, you go for the variables with the smaller coefficient. So you've got a 1 there, a 2 there, a 5 there, and a 1, so that's bigger. That's why I decided to drop that and rather go for this, because this will give you a smaller LCM. So if you've got a 1 and a 2, what's the LCM of 1 and 2? The LCM of 1 and 2 is simply 2. So that's why I've gone for P. If you decide, or if you decided earlier on to take 5 and 1, the LCM will give you 5. Now you will still end up getting your answer right, but like I said, I prefer to go for a variable with smaller values. That way you get, when you get to multiply, the values you get will not grow, or when they do, they grow slowly. And it's easier to do with smaller numbers than bigger numbers. So look at the LCM of 1 and 2, which clearly is 2. So the next thing you do is, with the LCM of 1 and 2 being 2, you have a 1 there. 1 times 2 gives you, so you multiply the whole of equation 3 by 2. So 2 times the whole of equation 3. Now, since the LCM is 2, and you already have 2 there, so nothing changes much. So you multiply the whole of that, equation 4 there, is by just 1. Okay, and that's what we have here. 2 times the whole of equation 3, and then 1 times the whole of equation 4. So equation 4 actually doesn't change because you multiply by 1. It doesn't change. However, equation 3 changes, because by the time you multiply the whole of that by 2, we will have 2 times P. 2P minus 10Q is equal to 4T. Right, so there you go, that's what we have. 2 times P gives you 2P, minus 2 times 5Q gives you minus 10Q, that is equal to 2 times 7 gives you 14. Now here, because that's different from all the equations we've got before now, we call that equation 5. But you see, by the time you multiply the whole equation 4 by 1, it's still the same, nothing changes. 2P plus Q is equal to 3, so that's still equation 4. So that's why we're not calling that equation 6, alright? So now, you can see clearly the coefficients are the same. And with the same coefficient, now check the signs. Now, like I said a moment ago, if you're paying attention, the signs haven't been shown here. And where the signs are not shown, it's automatically taken to have a positive sign. So it's positive there, meaning the signs are the same. And because the signs are the same, same sign, you subtract. The signs are positive, so we are going to subtract the two equations now. So when you subtract, let's see. When you subtract, clearly, when you subtract 2P minus 2P, that's 0. So P is eliminated. We've eliminated P. And then when you move on, again, clearly watch. Minus times plus gives you minus. So you have minus 10Q minus Q. minus 10q minus q. That gives you minus 11q. Okay, and then 14 minus 3. 14 minus 3 gives you 11. Okay, so there you go. And from here, to get q, it's quite straightforward. You simply divide both sides by minus 11. And so, q is 11 divided by minus 11. And that gives you minus 1. So you have the value of q. So given this value of q, you put this in equation 4. Okay, right there. Now I'm going to have to quickly erase those parts we don't really need. Erase that, so it's less confusing. Right, so we put this value of q, which is minus 1, in equation 4. So anywhere you see q, you put minus 1 to get the corresponding value of p. Okay, so there's equation 4, 2p plus q. So the q is now replaced with minus 1 is equal to 3. Right, so when you put the value of q, which is minus 1 in there, you have 2p plus or minus 1 is equal to 3. And plus or minus gives you minus. So you have 2p minus 1 is equal to 3. Now, you move the minus 1 to the right hand side, so you have 2p is equal to 3 plus 1. And that gives you 2p is equal to 4. And to get p, you divide both sides by 2. You do that, get as value of p to be 2. But then, you need to find the values of x and y. But remember, p is 1 over x and q is q is equal to 1 over y. And so, with p being equal to 2, you have p, which is 2, is the same as 1 over x. So to get the value of x, you simply move the x over there and then y down. So x is equal to 1 over 2. And y, to get y, remember q is minus 1. So you put minus 1 there to be equal to 1 over 3. And then again, the y goes up there and then minus 1 comes down. So y, value of y will be 1 over minus 1. And 1 over minus 1 clearly is minus 1. So these are the two values of q and, these are two values of x is half, right here, and y is minus 1. And then we can actually check in the equation. Alright, now I'm going to project the 3 remaining questions for you to try out. There's question number 4. Solve the following pair of simultaneous equations. 3 to the power of x times 3 to the power of y is equal to 1. And then 2 to the power of 2x minus y is equal to 64. Okay, try that. And then the next one, I've got 2 more. P over 3 plus q over 5 is equal to 4. And then p over 2 minus 3q over 2 plus 12 is equal to 0. And number 6, last but by no means the list. If 2x plus 3y is equal to 4, and 3x minus y is equal to 6, then x is what? Right. Now, these are the questions I would like you to try your hands on. I will try as much as possible to provide some more questions for you on the school portal. Having said that, we've come to the end of today's lesson. If you have any questions, you can drop me a mail or send your questions to my inbox, and I'll try as much as possible to respond to your questions. Thank you so much, and I'll see you next time.